everybody. Let's get away from this page. All right, so could you guys comment your names and I will fill in the register. So I've got, is that Joan? I forget what your tags are. I think that's Joan. Ooh. So, Becca, Fifi, Alex, Roddy, George, Sophie, Callum, Caleb, Joanne. Oops, have we got Charlie yet? No, no Charlie. Cool. Yeah, I got a new computer. Not for the sake of streaming math videos, but yeah, I got a new PC, so everything's running smoother, high def, the lighting's better, the screen's bigger, I've got a fancy keyboard, so yeah, good. Makes things easier. Thanks for noticing. Anyway, how are you guys? Papers have been marked. I will send you those in a minute because we're going to go through it today and tomorrow, possibly Friday, but we will see. Yeah. So I think first of all, I will send you guys your papers back, which might take me a second just to do, but yeah, thanks for getting those done, guys, and emailing them over. I know it was a pain to scan them. It was also a pain for me to turn your scans into actual markable documents, but I've done that, and those are coming back to you guys right now. So, Alex, yours has just sent. Becca, yours is too large to send. I'm going to send yours via Teams, Becca. Cool, that's just uploading. Caleb, yours is uploading now. Sorry, some of this is quite slow. Anyway, not bad. There's room for improvement from all of you, but it wasn't a bad set of results. Also, I don't know who did it in exam conditions and who didn't. I'm just going to have to trust that you guys did, but yeah. So I haven't put a grade on these papers because we haven't decided what the grade boundaries are going to be yet. Cool. Right, Caleb and Becky, you should have yours now. Callum. There's your one sent. Charlie. Any second now. Sorry, guys, this is an exciting start to the lecture. Charlie, there's yours. So as soon as these arrive, if you guys can have a flick through them. Fifi, yours is just uploaded, should be pretty quick. Yep, done. And Sam. George. Yours is maybe done. Yep, done. Joan. Yours is going to be a while. And then just Roddy and Sophie. So Roddy, I'm going to send yours via Teams. So if you could log on to Microsoft Teams, it will appear in a sec. Cool, there's yours ready. Joan, yours is almost ready. There you go. So Joan, yours is on your email, and Sophie, yours is just uploading now. Cool, job done. There you go. Sophie, you should have yours. Cool, so you should all have these arriving in your inboxes right about now. If you guys can look through them, I might give you 10 minutes just to flick through and have a quick recap of what's in the paper. Maybe make a note of some questions that you want to ask me. If there's any bits you weren't sure of, make a note of those, and then we will just start working through the paper. Yeah, hopefully by the end of it, you guys will be perfect at that paper. So just going to see if I can upload it. No, it's not there anyway, is it? Okay, well, while you guys look through it, I will set this timer and I will try and find a copy of the paper and put it up so we can start going through it. It's 10 minutes, have a look through, recap it, make some notes of things that you might want to ask about. Yeah, if you just comment any questions that you want to look at or any bits that you want to go over. Right, so okay, cool. I think we'll go through it all, but it's interesting seeing which ones you guys. Yeah, Joe, and I can't remember what you did for that proof. I'll have a look at it when we go through it, but there was a lot of weird stuff. All right. Okie dokie. So we'll go through it all, but I will gloss over the easy stuff because I don't want to spend hours doing the basic bits. Where are we? I did just download this. This one. All right. Interesting thing was this was the exam I marked last summer, so I do know all the insider market information. So first one, I mean, I can't remember if anybody got this wrong. You definitely shouldn't have got this wrong. So we need to find A, given that x plus 3 is a factor. So the idea here is to do... Sorry, I was just going to do a quick hack to... There we go. Okay, so we want to try and find out what A is. So we're going to do f of minus 3 equals 0. This is the easiest way to do it using the factor theorem. So we put minus 3 in, so we get 3 lots of minus 3 cubed plus 2a minus 3 squared minus 4 minus 3 plus 5a equals 0. 3 cubed 27 times 3. Can I do that in my head? No, I can't remember today. 64 is it? 81. Of course it is. We get minus 81. 9 plus 18a. What's that? Minus plus 12 plus 5a is 0. So we're saying 23a is 9, therefore is 3. So that was a nice 3-mark question to start with. To ease you all into it. What's next? Oh yeah. Okay. So part 1, use the diagram to show why that only has one real root. What you needed to do, and what most of you did, this was pretty good to be honest. You needed to use the diagram first of all. If you didn't use the diagram, you got no marks. The diagram is of cos x. So what we're trying to do really is trying to say this here is the same as when cos x equals 2x plus a half. So if I sketch 2x plus a half, which is a line with a gradient of 2 going through at a half, so it has to cross the axis at this point, and it has to have a gradient of 2. So for every 1 it goes across, it needs to go 2 up. So it needs to be quite a steep line. I'm going to try and draw this well because they're very picky about this in the mark scheme. So there's where it crosses. For every 1 it goes across, it needs to go up by 2. So it needs to go through that point there. And that point there. That's awful. That would get no marks. I don't know. Every 1 across, it needs to go up 2. So that's 1 across, that's up 1, that's up 2. Every one across needs to go 2 down, so that's there. Something like that. No, because that doesn't go through at a half. Oh my god. Terrible, 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 terrible. Nope. You guys, I can see why this is hard now. It's the first time I tried to do this. Something like that. It needs to roughly have a gradient of a half, and it needs to cross at roughly a half. They give you a little bit of leeway, but it was a bit tight, this question. So that's part A, and then you have to say, look, they only meet once. Therefore, there's one root. If you didn't do that, you didn't get the marks. So that was the first part of this one. Okay, given the root is small, use a small angle approximation to find the root. Okie dokie. So we're trying to solve this equation. Using the small angle approximation. So we're going to say cos x is the same as 1 minus x squared over 2. Take 2x minus a half. 0. That's what we've got to solve. So we're going to get minus x squared over 2. Take 2x, we've got 1 take a half, so that's going to be plus a half equals 0. Quadratic to solve. If I times it all by 2, we will get minus x squared. Let's see that. Minus x squared minus 4x plus 1 equals 0. Want to find its 3 decimal places, so we go on the quadratic equation solver. And we get x equals 0.26. Cool, that was it. Oh, I lost it. I've lost the questions. Oh, that was the first page, okay. All right, next one is page 2. Differentiation, okay. Okay. Basically, we need to do a differential, and you needed to really identify it was a quotient rule question. Somebody tried it product rule. I think it did it, but it wasn't pretty. So u is going to be 5x squared plus 10x. V is going to be x plus 1 squared. U dash will be 10x plus 10. B dash will be 2 lots of x plus 1 power 1, so just 2x plus 1. Cool. So quotient rule, v du dx. V du dx minus u dv dx. Be careful of your brackets as well. Divided by v squared. Cool. Now we just need to simplify it. So simplifying this, we're going to hope that the top will cancel to leave us with a number. So I'm going to expand everything on the top. Do I need to do that? Yeah, I think I do. So 10x plus 10 times by x squared plus 2x. That's 1. Take away, let's expand all these together. What's that going to be? 10x cubed plus 20x squared plus 10x squared plus 20x all over x plus 1 to the power 4. Cool. Okay, now we need to expand the top and start simplifying all this stuff. So 10x cubed plus 10x squared plus 20 squared plus 20x plus 10x plus 10. That's the first bracket. Take away, what's that? What have we got there? 10x cubed. Take away 30x squared. Take away 20x. Cool. So let's cancel some stuff. So we've got a 10x cubed and a 10x cubed. We've got 30x squared, 30x squared, 20x, 20x. So we're left with 10x plus 10 over x plus 1 to the 4. We can factorize that to get 10 x plus 1 over x plus 1, 4. That will cancel with that to give us 10 over x plus 1 cubed. There you go. That's how you do that. Part B, deduce the range of values for which the gradient is less than 0. So that's the thing we just got as an inequality. When is that less than 0? So the 10 isn't going to make any difference. I could divide both sides by 10 and we'd get 1 over still less than 0. So 10 doesn't affect it at all. X plus 1. I mean, we've got a cubic. Cubic, the sign is the same as it was to begin with. So all we really need to do is say when is x plus 1 less than 0? X plus 1 is less than 0 when x is greater than minus 1. Wait, no. X is less than minus 1. So that's the range of values for which dy dx is less than or equal to 0. Cool. Next one. Oh, that's that question done. Okay. Let me clear some space. Cool. All right, so we now have a binomial question. Part A is pretty standard. We'll come to part B in a minute. So expand this using the binomial expansion. Pretty standard question there, really. Hang on. Just lost. God, I've lost the chat window. Where is everybody? There we are. Yeah, I almost did that too, but Roddy. Easily done. Cool. Good. Okay. So we're going to write this as 4 minus, a bit big, 4 minus x to the power minus half. Now remember, to integrate this, we need it in the form 1 plus nx. So we need to take out a factor of 4. And the 4 I take out has to be to that power as well. So it needs to be 4 to the minus a half. So the first mark on this was doing that. If you got 4 to the minus half written anywhere, that was one of your marks. Now we need to expand it. So I'm going to leave the 4 on its own for a while. And we'll concentrate on the inside of the bracket. So we get 1 plus nx. N is minus a half. X is minus x over 4. Plus minus a half. Minus 3 over 2. Minus x over 4 squared. Over 2 factorial. That's all we need because it wants the first 3 terms. So there we go. And that is your second and third mark. So you got 1 mark for the 4 to the half. Next mark for having the first term, and next mark for having the whole thing correct. So without expanding it, we've already got 3 out of the 4 marks. So it's really important with binomial that you do it all before you start actually simplifying. All right, so we're going to get 4 to the minus a half. It's going to be a half. 1 plus x over 8 plus, what's that going to be? 3 over 4 times by 1 over 16 divided by 2, 1 over 32. Is that right? Ooh. No. 8 times 4 times 2. 60, is that right? 64? I'm sure it should be more than that. Yeah, sorry, it should be x cubed over 128. Like that. And then we have it all to get half plus x over 16 plus x, that shouldn't be cubed, that should be squared. X squared over 256. Cool. Right, so that's part A. And just so we remember, what we expanded was 1 minus x over 4. Was that. Right, let's move it all down. So, without doing it, explain which of these would be the best. All right. There we go. So, trick here is looking at, so which of them should not be used? Well, one of these isn't valid. Remember, it's valid for x over 4 less than 1. If we times both sides by 4, we get modulus of x less than 4. So if the value is more than 4, it shouldn't be used. So 14 should not be used. So what you needed to say for that mark there is minus 14 should not be used outside the range. And you need to state the range as well. So that's what we needed for that mark. Part 2, state which of the values will lead to the most accurate approximation. Well, the most accurate would be the one closest to 0. So the one closest to 0 is minus half. So is closest to 0, therefore most accurate. How do you... because whenever you do a binomial, it's always valid for the x bit is less than 1. So if you're expanding 1 plus x to the n, this is valid for x is less than 1. Our expansion was 1 plus x over 4, 1 minus x over 4 to the n. So that's the bit that's less than 1. So we get x over 4 less than 1, therefore x less than 4. Roddy, 4bi. Okay, let's do that right now. Oh, I see. Okay, yeah. It's not the normal way you'd write it, but yeah. Okay. Normally you ought to find the range of values and compare the range, but you've put the value into the range. Um, I'll give you it, but I do think you should try and do it the other way because your way isn't actually in the mark scheme. Yours is the kind where I would probably award the mark anyway, but I think most markers would possibly send it further up the line to somebody higher up. So yeah, I'll give you it, but in future, try and find the range first. Let's update that now. Cool. So that'd be one more mark, which is one more percent. So yeah, one more percent on your grade. Cool. Okay. Yeah. Any other questions about this? Are we all okay? All right. What's next? That's the end of that one. Okay. We're in pretty off time. All right. Question 5. I think question 5 is the easiest on the whole paper. To be honest. It's just like it's a nice wholesome question. So starting off with some completing the square. No, I've lost it. Where's the equation? There. So we got 2x plus 4x plus 9. So I'm going to take out factor 2 first of all. Then complete the square. Then expand. So you should be getting that. Nice and simple. Then we got to sketch that curve. So to sketch this, we know the minimum point is going to be at -1. Can't see that. -1,7. And we know from the beginning of the question, it cuts the axis at 9. So that's your full sketch there. So it was 1 mark for the shape, 1 mark for the y-intercept, and 1 mark for the minimum point. Oh, and just to be clear, if you had drawn this, a bit of a rubbish bit at the top, you'd lose a mark for the shape. So they are quite picky about how these look. Okay, describe fully the transformation that maps this curve onto this curve. So, what I would suggest is looks like we got x take 2. Try to work this through. Yeah, there's a few ways you can do this. It depends if you spot it. So what I would be looking at is the fact that there's now got x take 2 in brackets. Yeah, there's a few ways around it. Yeah, I would imagine. My guess would be this is f of x take 2 with something else. If it was just f of x take 2, let's have a look at what would happen. So if it was just f of x take 2, our original function up here in red would become 2x take 2 squared plus 4x take 2 plus 9. We could expand, we'll keep the front bit the same because those are the same thing already. If we expand all the stuff over here, 2x take 2 squared plus 4x take 8 plus 9, which is 2x take 2 squared plus 4x plus 1. So you can see, yeah, it looks like it started off as f of x take 2, and they've done something to the y. So the y value I make is 1, theirs is minus 3, so it looks like they've moved it down 4 as well. So I imagine it's f of x take 2, take 4. That's how I would go about this. Of course, you could sketch both on a calculator and do it like that, or you could expand it completely and then recomplete the square, and that would be a nice clear way of seeing what's gone on. But yeah, either way, I make it a translation horizontally of so plus 2 in x minus 4 in y. You could do a 2 minus 4 as a translation as well if you wanted to. Does that make sense for everybody? If you do it on the calculator, you can see it. As long as you've said the answer, they don't care. Let's have a look. CI. I need the full mark scheme. Give me a sec. I do have it here somewhere. Okay. Yeah, so if you did that in the exam on the calculator, you would get all the marks. You got 1 mark for having one of the translations correct, 2 marks for both of the correct translations. You could draw it in your workings. You don't actually need to. It was 1 mark for the method mark was deduces translation with 1 correct aspect, and the other one was the actual what it is. So yeah, you could have used your calculator. It says it here, using a calculator to sketch and compares to the sketch of the other one. Almost all cases, yeah, that's it. So you got it. Calculator fine for that question there. Obviously, it's best if you can do it with the maths because it shows your mathematical ability, but yeah, using the calculator is fine for that. Okay, is that the whole thing? Okay, find the range of it. So, what have I done? Right, I don't know where it went, but whatever. So we've got basically we've got to try and find the range of this function, and this function is 21 divided by the function that we started with. In other words, it's 21 over. So again, you could just do a sketch of this if you wanted to. Yeah. So basically, it's a 1 over x graph that's been stretched. So if we start with that 1 over x, that's 1 over x squared, which looks like this. So we know the lower limit is going to be 0. So 0, y. We need to find what the maximum of this value is. Well, if we think about the maximum of the quadratic, the maximum of that quadratic we're going to need the minimum, aren't we? Okay, the maximum of this curve we're trying to do is going to be when the denominator is minimized. Does that make sense to everybody? If we think of the maximum, 21 divided by something. So it's never going to get, well, the minimum it can be, well, the maximum it's ever going to be is when we're dividing by a minimum value for the quadratic on the bottom. So what is the minimum value of the quadratic on the bottom? It's 7, because remember our quadratic had a minimum of 7. So we maximize the 1 over x graph when we minimize the denominator. Min of the denominator is 7. 21 divided by 7 is 3. Yeah, we can equal 3. So that's the way I would go about this one. Or you can sketch it on the calculator. But I would try and think my way through it kind of logically. For that one. I'll see what method they used actually. But that's how I would do it. Yeah. So what they've said in the mark scheme here is that the bottom curve, if I call the bottom curve f of x goes from 7 to infinity. So if you imagine it's infinity, 21 divided by infinity is going to be pretty much 0. That'll never get there. That's what our asymptotes are here. And the other value 7. If you put 7 in, 21 divided by 7 is 3. That's going to be our maximum. So that's why our g of x has this range, whereas our f of x has that range. Hopefully that makes sense to everybody. Cool. Right, that brings us to trig. So question 6, trig. Solve this. So solving this, we want to put it all in terms of one type of trig. We've got a mix of sine and tan. Let's turn it all into sines and causes first. So we're going to get 5 sine theta cos theta times 2, which is actually going to be 10 there, equals 9 sine theta over cos theta. So I'm going to times both sides by cos to get 10 sine theta cos squared theta is 9 sine theta. Get it all on one side. And factorize out the sign. If you divide it by sign, you've lost the mark. So factorize out the sign. And then this leads to two sets of solutions. So we're trying to solve it between 180 and minus 180. So if I solve this, the two sets are going to be sine theta 0 or cos squared theta is 9 over 10. Okay, so solving these from 0 to 180. So sine looks like this. Oh, no, like that. Cos looks like that's awful. Worst thing I've ever done. Let's just redraw it, yeah? Yeah. Okay, so I'm going to redraw as soon as the iPad stops freaking out. So draw cos first. I think that might make things easier. There's cos, sine. Yeah, that'll do. So that's up to 180. So when is sine 0? Well, there's a solution there, there, there. So for this one, we get minus 180. Can't see that. Minus 180, 0, 180. Cos, well, we need to square root both bits. So we're going to get cos theta is plus or minus 3 over root 10. So if we find our principal value, so we do arc cos 3 over root 10. And we, am I in? I'm in radians, change to degrees. So we get 18.43 degrees. So that's going to be about up here. Now I could do the negative one as well, but it's just going to be symmetrical. So it's just going to give me minus 18.43. But if you don't believe me, you can do that. No, what am I talking about? Chatting rubbish. So then we do cos the minus 1 of minus 3 over root 10. And we get 161. So my other solution is here, 161.6. So the other angle we need is there. So we're going to get for cos, we get plus or minus 18.43 plus or minus 161.6. So there are actually 1, 2, 3, 4, 5, 7 solutions, 4 there and 3 there. And you need to say all of those. Okay, next bit. Deduce the smallest positive solution to this equation here. So I'm going to make a bit of space. I'm going to write my solutions at the top. So we got there we go. So we want to find the smallest positive solution to this equation here. Now it's the same thing as we had earlier. The only difference is we now got theta minus 25. So all those angles we just found, x minus 25, we could say is equal to all of these things. And we want to find the smallest positive solution. So you could work them all out, or we can just look through them. Well, the only ones that it might be are the middle ones here. So the others, if we add 25, that's still going to be negative, still negative. If we add to these, well, there's a positive below that. So it could be any of these. If we have a quick think about it, if we add 25 to 0, we get 25. It's pretty small. If we add 25 to 18, we get 43. So that's less small than 25. If we add 25 to minus 18.4, we get a very small positive. So we're going to say x take 25 is minus 18.4. So x equals, I think we get 6.4 or something. 6.6. That should be your answer to that one. Cool. All right. What's next? Okay, car model. Cool. So we've got use an exponential model. This had mixed results. Some of you did all right on this, some of you hated it. There's a few ways you can do it. I know the way I always do it. I'll show you that, and we'll have a think about other ways. If it's an exponential model, I always jump in by going, okay, v equals a e to the kt. Basically, I'm taking an exponential, e to the x, squashing it and stretching it in the vertical axes. So I'm basically forcing it to fit my data. So I would always start with this. There's other ways of doing it though, but this is what I did in physics and this is what I've stuck with now. So I'm just going to put my values in, get two equations, solve them simultaneously, find A, find K. But there's about 4 different models you can use for this. So if I set all my models up, we're going to get value in its new is 20,000. So 20,000 equals A e to the, well, new is T is 0. So we get A e to the 0. Which other words gives me 20,000 equals A. The other one we know is 16,000 equals A e to the K. We know 20,000 is A, so 16,000 equals 20,000 e to the K. And I can find e to the K. So 16 divided by 20. Learn that. And I get K is minus 0.223. So that will work. There are other ways of doing it. You could do it exactly, and instead of having e to the k, you could have learn something. So you could have, yeah. But anyway, so that's my model. I'll write down all the other options. But there's so many different ways to think about this. So we're going to say v equals 20,000 e to the minus 0.223 t. That's my preferred methods. Other methods you might have had were v equals 20,000 0.8 to the power t, I think was a good one. Yeah. Yeah, there's a few though. There's a few different ways you can do this. Anyway, so we got a value. There's a couple ways doing it, but whatever you guys did, you know if it's right or wrong. Okay, now we need to evaluate the reliability of our model. So they told us after 10 years it's worth 2,000. We need to see what our model suggests. So I'm going to put 10 years in, so t is 10. So 20,000 times e to the minus 0.223 times 10 gives me 2150, which is pretty close, I would say. Being out by 150, that's a pretty good model. So I'm going to say good model, only out by 150. You could have also worked a percentage difference and said, yeah, it's good, it's this many percent out. You could have said it's a bad model, as long as you said 150 is too far out. Okay, you can say it's too far out. You cannot say it's a bad model because it's not the same. A model is never going to be the same. Model will never be 100% accurate, so you can never blame a model for not being perfect, basically. So yeah, you can say yes, it's good, or no, it's bad, but you have to be saying because of the amount that you're out of sync by. You can't say it's not the same. So that's the point there. So yeah, I'd say a good, reliable model. And then we got the following information available. So we got a different car that has the same initial value, but it depreciates more slowly. And you needed to evaluate this in terms of your model. So if your model was like mine, we need to figure out how we can get this to age slower. And for this one, it's going to be to make minus 0.223 less negative. So make k less negative. So it's going to be somewhere between, like that. Cool. So mine's kind of like increasing k. You might have, if you had 0.8 as your value, you might want to make 0.8 smaller. So it depends on your model what your answer was. But yeah, so you could either say make k less negative, so we're increasing k, or we could be decreasing the 0.8 in your equation. Cool. That's the whole question done. Nice. How are we doing? 25 minutes. I don't think we'll finish it, but we're going to get pretty close. So we might start. Oh, wait, I need to do that PowerPoint. Might leave that for today and do the PowerPoint because I've just done 7 questions in a row. I'm a bit knackered. Oh. Yeah, okay, so we got to question 8. I will write FM Tuesday. And I need to show you guys a PowerPoint. So I'll keep that all saved. That is good to go for next time. Let's have a look at this PowerPoint. June PowerPoint. Is it June 1 or June 2? I think we need to do both. Let's do both. So I will put the. Do I have PowerPoint? I don't even know if I've got PowerPoint on this computer. Microsoft PowerPoint. Way, I do. Cool. Okay. I haven't actually used this yet, so. But okay, it's open. Cool. Right. I'm just gonna try and do some magic. So hide the whiteboard. Add a new screen capture. Create new PowerPoint. Microsoft PowerPoint. Nice. But it's taken my face out of the way. Hey, there we go. Cool. Right. So we're in PowerPoint, and I've got to show you guys 2 different presentations. Yeah. Okay. So let's start with the June 1 PowerPoint. You guys see that? No. What's happened there? There we go. Cool. Right. I don't know what's going to happen if I make this full screen. Give me 2 secs, guys. I've not actually tried this before. I'm just going to go on my phone. What's Roddy saying there? No. Just going to go on my phone and see if I can check, because I don't want to show the wrong thing. Basically, I won't be able to see your comments if I go on to there. Oh, I'll do it on the iPad. I'm not even logged on. Oh my god. World maps, where are we at? There we are. Cool. All right, I can do this. So this is going to go full screen, and hopefully this will work. I'm just waiting to see if this works on the iPad because I can no longer see anything. Nothing's happened yet. I feel like this is not working. Okay. I mean, it's a nice idea. I can just do this. I can cheat. Okay, cool. We got it. We got it. Look at that. Didn't get GCSE ICT for nothing. All right, there we go. There, cool. Okay, so I'm hoping you guys can all see this now. God, what have I done? Okay. Whatever, that'll do. Okay. So it's time for another PowerPoint because we love our PowerPoints in Further Maths. So yeah, because it's up to, well, some of you, you might not all want to do Further Maths next year. You might just want to stop and do your single maths. So you got to decide. So why would it be good to stay on Further Maths? 18 reasons. So the first reason, understand maths and mathematical processes in ways that promote confidence, foster enjoyment, and provide a strong foundation for progress to further study. Extends your range of mathematical skills and techniques. Understands coherence and progression in maths and how different areas of maths are connected. Apply mathematics in other fields of study and be aware of the relevance of maths in the world of work and situations in society in general. Use your mathematical knowledge to make logical and reasoned decisions in solving problems both within pure maths and in a variety of contexts, and communicate the mathematical rationale for these decisions clearly. All right. Reason logically and recognize incorrect reasoning. Yep, that's good. Generalize mathematically, construct mathematical proofs, use your maths and techniques to solve challenging problems which require you to decide on the solution strategy. Recognize when maths can be used to analyze and solve a problem in context. Represent situations mathematically and understand the relationship between problems in context and mathematical models that may be applied to solve them. Draw diagrams and sketch graphs to help explore mathematical situations and interpret solutions. I think I just got an email. I've got a meeting in 15 minutes. That's good. All right. Make deductions and inferences and draw conclusions by using mathematical reasoning. Interpret solutions and communicate your interpretation effectively in the context of the problem. Read and comprehend mathematical arguments, including justifications of methods and formulae. Yeah, loads of stuff. Loads of reasons. Reasons are good. Okay, so you've completed the content for A-level maths. Provided you make sufficient progress, I think, don't quote me on this because we haven't completely discussed. I think that's what this meeting's about. I think the results you guys got in the tests were enough for you all to progress to Further Maths next year. I will double check that. Some of you are close, but I'm pretty sure you all made the cut. So for now, I think you're all safe. Callum's just asking me how much harder is Further Maths than Maths. It is harder, but you all should be able to cope. You've all coped with A-level maths in 1 year, so you should all be able to cope with Further Maths. If we didn't think you'd be able to cope, you probably would have failed that mock. So you probably all cope with it. It is harder. It's more complex. It's bigger ideas is how I would describe it, but it's I think it's less than the jump between GCSE and A-level, maybe slightly less. It's different maths ideas. So you've completed the content. If you're finding the course too difficult, you can change to a free A-level program by dropping maths and retaking year 2 of A-level maths. When do we go to our job stats? Possibly soon. That's PowerPoint 2. Anyway, so if you want to keep doing maths, great. If you don't and you want to swap it to just do finished maths, well, yes and no. I mean, some places do AS maths, first year maths, and first year further maths, followed by second year maths and second year further maths. So we'll be starting next week with AS, first year further maths. So the easier bit of further maths. And then we'll be doing the harder further maths stuff next academic year. So yeah. So yeah, it's supposed to be 2 years, but it's not really. We're just teaching in a different order. We've done the hard bit of pure maths. Now we're going to do both bits of further. Anyway, so that's that bit. So if you want to keep doing it, great. Let me know if you don't. Progression to year 2, you'll need to keep A-level maths active next year, especially those of you who've taken the exam already. Especially those of you that haven't taken it already. So the revision questions on assignment are designed to keep you guys going with the stuff we've already done. Several universities have extra admissions requirements. Okay, so there are Year 2 Maths Academy classes that commence in September that will help you if you want to go do maths at university and you need to do an entrance exam. That's what you need to sign up for. You need to do Maths Academy so you can do those extra hard papers to go do maths at university, which some of you really recommend you doing it, or physics or engineering. Some of you are very, very, well, all of you, to be honest, are very good mathematicians. What have I done? I've just skipped a load of pages. So yeah, let us know if you do need to do entrance exams for university. You will study further maths content in year 2. So proof, there's further maths proof, complex numbers, that's imaginary numbers, polar coordinates, so it's a different coordinate system, matrices, vectors and geometry, more differentiation, further differentiation, series expansions, further integration, hyperbolic functions, differential equations, and then there's some options. So you guys get to choose from further pure, further stats, and further mechanics. So we'll come into that in a minute. We are able to offer a choice of options. So further pure, which is people who might want to study a very maths heavy degree course. Further stats, which is some useful extra stats tests and some mathematical theory. Further mechanics, extending the theory to deal with more complicated situations. So depending what you guys found most interesting, you get to choose those. And I think it's 2 of those, but we'll see that on the next slide. So yeah, we want to know which 2 options you would prefer. And we want you to make your choices on Moodle. Your first vote only will count. The classes will then be reshuffled to give the best fit, but we can't guarantee you that we'll be able to teach all of those options. We're going to do what the majority say. If the majority split perfectly, then great. If they don't, we'll try and accommodate all options, but we might not be able to. Decision, we don't offer decision as far as I know. We used to, but I think it's changed in the new syllabus. So those are what we're saying. Pure, further stats, further mechanics. Okay, exams then. So A-level maths is in 3 papers, paper 1, paper 2, and paper 3, which is stats mechanics. Further maths is 4 papers, 2 core maths papers, and paper 3 for option 1 and paper 4 for option 2. So yeah, you either have to do stats or mechanics. You have to choose one of those alongside further pure, or you could get rid of further pure and you could just do stats. You could do exactly the same as you did this year, but further style. Up to you guys. So yeah, that's how it's going to be broken down. So those of you who are doing maths and further maths next year will have 7 maths exams in total. Remember though, so if you're doing stats mechanics anyway next year, it could be useful to do stats and mechanics as well. So it's, I don't know, have a think about it. You've got at least a week to decide. Test assignment, tests throughout the course, initially every couple of weeks, but less frequently after that. You got home assignments, we've done this before. It's the same as last year. Homework, start the revision, this is just to recap and reiterate. Do the revision questions first, then do the new material. Answer all the questions. We'll be very strict on you next year because you guys should be our elite mathematicians. Everything should be done perfectly. Yep, been through this. You need to enroll on the 2nd year Further Maths Moodle. So if you type in Further Maths 2020 Year 2, that's the course you need to enroll onto. We expect 100% attendance, working hard, completing homework on time. You can expect challenging, exciting course, fast pace, expectations, help and support, regular feedback. Cool, all right, that's PowerPoint 1. So let's blast our way onto PowerPoint 2. Which is all about options. Now, this one, I'm not so keen on the paint color or the color scheme of this PowerPoint, as you guys will see. And we do have to finish early today because I've got this meeting, but see, is that right size for you guys? Yeah, just about. Okay, so further maths options. Part 2, you of course need to choose 2 of the options. So I said already, further maths, further mechanics, further statistics, or further pure 1. This PowerPoint will help you decide. So think about what you enjoy in maths. Consider what you might need at university. If you're going to do physics, do mechanics. If you're going to do economics, maybe do statistics. If you're going to do maths, further pure 1. So you should not pick an option because you think it looks easy. You should not make a choice based on your friends. Same style as the guy from Virtual Pub Quiz. Oh, really? I didn't know that. Chris has made this. He must have stolen it. So make your choice based on friends' decisions. Cool. Right, further mex 1. In further mex, you'll study momentum and impulse, solving problems involving collisions, involving the conservation of momentum, and using the impulse momentum principle and the conservation of momentum in vector form. So if you've done momentum before, vector form of that. Work, energy, and power. Work done, kinetic energy, principle of conservation, mechanical energy, and power developed by an engine. So all ideas that you might have already met in physics. Elastic string and springs. So Hooke's law for equilibrium problems, Hooke's law for dynamic problems, finding energy stored in an elastic spring, and solving problems involving elastic energy using the principle of conservation of mechanical energy and the work energy principle. Okie dokie. Elastic collisions in one dimension, so problems involving the direct impact of 2 particles or 1 particle with a smooth plane surface, so things colliding into walls or things colliding into each other. Elastic collisions in 2 dimensions, so yeah, we talked about that already. Walls with spheres colliding. Okay, further south. So it's mechanics still. Just some new topics. They're not necessarily harder topics. I will say that they're topics. Some of those topics used to be in the old A level. They're just more mechanics. Further stats. Again, more statistics. So discrete random variables, which you'll have done a bit of in stats, but we go into it more detail. Again, this used to be in the old A level. I quite like DRVs. They're quite fun. It's all about gambling. So expected values, variance of discrete random variables. Poisson distribution, so you finally get to use the other distribution on the calculator. Models the number of times the event occurs within a fixed period of time, so the frequency of meteor strikes. Yeah, so again, looking at the times an event occurs in a fixed period of time. And we can use Poisson to approximate the binomial distribution. We also look at geometric and negative binomial distributions, so that's quite interesting. So for example, the number of times a learner driver needs to take their theory test before. Poisson does mean fish in French. I think it's a French mathematician who might have had fish as a surname. Anyway, you will understand. So, yeah, it's another distribution, and then negative and geometric binomial distributions. Different type of binomials. Further stats hypothesis testing. So we can use the geometric distribution to test. So time elapsed between weather events, testing the mean of a Poisson and the parameter p in a geometric distribution and finding critical regions. So similar stuff to what you did in A2 stats there, really. Central limit theorem, which is the distribution of sample mean when the distribution of the population is unknown. So it can infer how likely the views of sample are to be representative of a population. And we'll apply that to other distributions. And chi-squared tests, again, is another test to see how likely your results are to be true. So used in genetics to help decide whether an experiment was fair and unbiased and provide a level of confidence. So these are used a lot in biology and economics, chi-squared tests. Probability generating functions, so it's a function that generates the risk. So you'd use these in insurance companies to work out the probability of a risk happening. And we use those for distributions and use them to find variance and mean. And quality of tests, so it's how likely your hypothesis test is. So you've got type 1 and type 2 errors. You might have come across these before. They definitely used to be in the old A level, but type 1 and type 2 errors, different types of errors that can occur in a hypothesis test. So it's good stats. It's not first year weird stats. It's topic, probability, sense, data. I don't know. I like it. It's good. Okay, further pure one. So we'll look at vectors. So we look at the vector product, otherwise known as the cross product. It's very important in physics and mechanics there. The scalar triple product to interpret volumes. Vector equation of lines. So look at further vectors. Look at conics, which is basically the equations of cones in 3D. So rectangular hyperbola and parabola. Find equations of tangents and normal to these as well. Understand the locus directrix property of a focus directrix property of a parabola. So looking at where these things focus, and locus problems involving the parabola and rectangular hyperbola. Okay. Further math, further pure, you'll study conic sections 2, which is ellipses in Cartesian and parametric equations, loci, directrices, and eccentricity of an ellipse. So that again, I'm trying to link all this into physics now. Eccentricity of orbits is a big astrophysics topic, and then simple loci problems. Okay, inequalities. So manipulating inequalities with algebraic fractions, graphs for inequalities, and solving inequalities involving modulus signs. The T formulae, so converting trig to algebraic equations, solving equations and modeling. So again, kind of further trig there. Taylor series expansion, kind of, you guys have seen a bit of expansions of your binomials. Taylor series, again, I know this from when I studied physics. You can expand sine, cos, e to the x, log of x, and use them to find different solutions to differential equations. I have to race through this, guys, because I've got my meeting starting right now. So there'll also be further calculus, including Leibniz's theorem for differentiating products, L'Hopital's rule, and tangent half substitutions. There's a lot of it, but if I said all the names of the stuff we did this year, you'd find it difficult as well. So yeah, it's further maths. It is a bit more difficult, but it's more interesting. It's pure good maths. It's all stuff that you would come across at university if you did most types of mathematical degree, and it'll definitely help you out with those. Further pure numerical methods, Euler's method, Simpson's rule, reducible differential equations. Remember, you're only choosing 2 of these three modules. Okay, so you should think about what you enjoy in maths, consider what you need to study at university, and don't pick something because it looks easy or make it based on your friends' decisions. Cool. All right, so have a think, guys. Make your choice on the Further Maths Moodle. I think that's the Year 2 Moodle, but it might be on the AS one. Have a look. Anyway, I gotta go. I'll see you guys tomorrow. I can answer any more questions like this tomorrow. This PowerPoint's up there as well if you want to look through this PowerPoint in a bit more detail. But yeah, I gotta get off to this meeting. All right, cheers, guys. See you tomorrow.